Welcome back to week 9, and in video 2 we're going to move forward and talk about how we use fossils, rock units, landforms to help us figure out and interpret what's happened in a specific location in the past. So what do we do? Well, we can determine a depositional environment for sedimentary rock. We can look at an igneous rock and tell if it's intrusive or extrusive. We can even determine what type of volcano could have been at that location. And if we see metamorphic rocks, we might be able to determine if we have a plate boundary nearby. Now, once we have all this information and we determine what rock type is where, we can organize this data into geologic maps and into a geologic time scale. So, for example, we can take a look and find sedimentary environments like lakes, rivers, glaciers, desert environments, beach, reef, things like that. And we can say, okay, this area used to be a beach environment, or we see salt deposits, this place used to be a desert, or river, so on and so forth. For igneous rocks, well, depending on their texture, if they're coarse-grained, we can say, hey, this is an intrusive igneous rock. This was a pluton that formed way down inside the earth. In the gorge, we see a lot of basalt flows, so that tells us, hey, we've got an extrusive igneous rock, basalt's flowing highly, low viscosity, so it can travel very far. Volcanic breccias, explosive volcanoes, so those rock units, not only the texture but also the composition can tell us about types of volcanoes that might be present, like shield volcano, basalts, low viscosity magmas, cinder cones, gases present, composite volcanoes, very, very explosive eruptions. We can also look for metamorphic rocks. If we see metamorphic rocks, that's a sign that we have some type of change that has occurred in that environment. So it could be convergent plate boundary, high, very intense pressure. We could also have igneous intrusions that can cause change, and possibly we can have some hot fluids that can change rocks as well. So we can use these cues that you guys have learned about in past units of this course to help you kind of figure out what has happened in an area. Along this note, you can also not only look at the rock units, but you can look at the landscape, like landslides, or you can see maybe erosion from rivers, and any kind of currently active geologic process or evidence of a geologic process that once happened but isn't happening today. Once we can figure out what's happened in different places, so maybe across a state, across a river, what geologists do is they can create what are called stratigraphy units, and they organize things based on their oldest at the bottom, youngest at the top. They determine what rock unit is what. That's why there's different colors. And then we can also say, okay, well, I see two rock units that are very similar to each other. Maybe they have the same fossils in them, they are the same age. And we can correlate them maybe across a couple miles or maybe across an entire state. So we can correlate rock units that are the same over vast distances based on some of these sections that we can get by examining the stratigraphy or the geology in an area. This has been done with the Columbia River basalts. Geologists have looked at various deposits of these Columbia River basalts and determined what the chemistry is, can actually determine individual flows within the whole huge unit of the Columbia River basalts, and then they can correlate them to one another. So those are some of the methods. This is kind of a review. You've been learning all this stuff throughout this whole term to be able to recognize different geologic events and rock types, interpret that, and to say what happened in that area in the past. So we're going to use all that information that you've learned to help you determine the geologic history of an area. So we'll come back and talk about how we date them.